What's up, everybody? Today is March 11th, 2025. Going to go ahead and do another day of Leetcode problems. Wasn't able to really solve yesterday within the time limit that I had, so I was able to solve it off screen, but I wasn't able to solve it recording, so I didn't really post it. Anyway, let's go ahead and do this. Wow. What the? Let's do that over. I feel like I'm getting too nervous typing now because I had gotten that one really high streak. Oh well, let's go ahead and just check the problem out. 1358, number of substrings containing all three characters. Given a string S consisting only of characters A, B, and C, return the number of substrings containing at least one occurrence of all these characters A, B, and C. This question is very close to yesterday's. The biggest difference is we only have to keep track of three values, A, B, and C. For trailing values, so we know if once we find one, this is considered one, right? Then once we find this new value, we need to get rid of this duplicate, which is an A here. So we need the index to the last one. Okay. Okay, so on the last one, what I kind of did was I had a left pointer uh, count the number of leading values to get to this value. I don't think I really need a left pointer. All I need to really track is the character I found, correct? Um, okay, so we have the new one is A is equal to 3. Hmm. Oh, I see. We want the index of the furthest left thing, right? So in the case of A, if we had found A, it would be A. If we didn't have a value, then we'd get -1. Every time we find a new string, it is +1 plus the leading. A, B, C. So would everything leading up to this be like a prefix? So if we're here at A and we hit A, it would be A, B, C, A because it would have two A's. So A would be an additional string. Hmm. I feel like I don't need an actual sliding window for this problem. Right? So if I hit here, you would have cab, B cab, and AB cab. The furthest minimum back would be A. Which is a one plus it would be 1 plus 2, right? 1, 2. So it would be, I don't know if I'm doing this right. 3 minus the minimum. No, because what if it's -1? Okay, if we have 1A, the minimum would become -1. You'd add 0. Okay. So if I don't have something, and I'm already adding 1 because of the new thing, If I didn't actually have 1, it would subtract 1 and add 0. But if I said the minimum and I have them all, say A, what if instead of minimum I say maximum? Right? No, because then I would get this. Here and here. This is the point at which we have up to trailing, right? Minimum. Oh, wait, hold on. We go A, B, and then we hit C, right? Minimum for ABC would be 0, which would be this. Oh, I'm thinking about this wrong. So you hit C and you would add 1. If I do this, it would actually be B, which would be 1, which would be 2. Because we've just reintroduced, right? So this would just be the minimum of the 3. And it basically uses the same concept of the leading or the trailing characters from the last problem. But it doesn't need a sliding window to do it. It's basically the same concept though. So let me explain what I was thinking. So if you have A, B, C, A, B, C, right? 0, 1, 2, 3, 4, 5, whatever. And we say we have A, B, C, right? This would make A equals 0, B equals 1, C equals 2. The minimum of A, B, C, right, would be 0. So you would have 1 plus 0 equals 1. You add this to the result. Okay, so we go to the next value, A. Okay, A now takes over A. So we have A equal to 3, B equal to 1, and C equal to 2. Right? So then you go 1 plus, and then the minimum of the 3 values is 1. All right, which is equal to 2. So you add the total. So 1 plus 2, 3. Okay, so now we're on B. We say A, B, C, A, or I'm sorry, we say B is now 4. So let's go A equals 3, B equals 4, C equals 2. And then we just say the minimum, which is 2. So we go 1 plus 2 equals 3. And then we add 3 to our total. So 3 plus 3 equals 6. And then we go to the last value, which is C. So A equals 3, B equals 4, C equals 5. Minimum being 3. We go 1 plus 3 equals 4. And then 4 plus 6 for our total is equal to 10. And that gives us all the substrings. Okay. Oh, I forgot to tell you before I already had 3. So if we have before A, B, and C, right? Say we have, I don't know, A, C, B. Okay. And we're starting at the first A. We say A is equal to 0. Well, the minimum of the 3 is -1. Ooh. So if we go 1 plus -1, it's equal to 0. And that just says that, hey, we haven't found all three values yet because we still have negative ones, right? So it just negates the negative one. Same thing if we set a equal to 1. You know, a equal 1 means there's still negative 1. A equals 2, still negative 1. C equals 3, negative 1 because of B. And then finally, once we get this, the last index of A is our minimum, right? And we have two trailing characters. And if you remember, not really remember, but if you have two trailing, you would add 2 plus the one string that you just got, right? For trailing values. So 2 plus 1 is 3. And so if you check the solution, it is 3. And that's basically how you solved yesterday's problem too. You're like, okay, well, I have a trailing value. Let's add up the trailing characters that you would add up all the way up to the point that basically negates the window. And then you add those trailing to the result plus the 1 for the string. And that's today's problem, which today's problem's significantly easier than yesterday, that's for sure. And it helps that they use the exact same concept. Anyway, that's all I had for the day. I hope you have a wonderful day. Come again. Have a good evening. Peace.